Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's this is not today's well, it is considered an easy level puzzle, but it's an other type of puzzle. So it's not a normal Sudoku variant. Um so I hope you enjoyed this. This is called Shikakawake. Shika Shikakawake. Shikakawake. And it's by Michael Lefkowitz. And here are the rules. We have standard Shikaku and Heiawake rules apply. What are these rules? And it says rectangles have one Shikaku clue and up to one Heiawake clue. What are these rules? We have Shikaku, which is divide by box, where the rules are divide the grid into rectangles with the numbers in the cells. Each rectangle is to contain only one number, showing the number of cells in the rectangle. So for example, from the solution, you can see that every 2 has 2 cells in the region, in the rectangles. Every 3 has 3 cells in the rectangle. Every 4 has 4 in the rectangle. There's a 6 with 6 in the rectangle, an 8 with 8 cells in the rectangle, and a 9 with 9 cells in the rectangle. So every circle is part of a rectangle, and it only has every circle is part of a rectangle, and you divide the grid into these rectangles, which must contain a digit for every region or every rectangle. And that digit is the size of that rectangle. So one thing is you can't have you could have a 7 rectangle. It's a 7 by 1, right? But the ones that are that can have more than 2 rows and 2 columns, or more than 1 row or 1 column, in more than 1 row and 1 column, have to be 4, 6, 8, and 9, right? I guess you could have larger digits. But anyways, that's the Shikaku rules. We also have, combined with that, Heiawake rules, where a rectangle bordered by bold lines is called a room. Fill in cells under the following rules. The numbers indicate how many painted cells there are in a room. So if you notice, there's a difference between one has circles with the digit inside them, so black circles with a digit inside them, and the Heiawake has essentially just numbers by themselves. So those are, I think, are how you differentiate the Heiawake versus the Shikaku numbers. So a rectangle bordered by bold lines is called a room. Fill in cells under the following rules. The numbers indicate how many painted cells there are in a room. Rooms with no number may have any number of painted cells. So if you don't have a number inside, a black digit inside of a square, you can have any amount of painted cells. White cells cannot stretch across more than 2 rooms in a straight line. So that means across more than 2 rooms in a straight line. So that means once you have 2 rooms worth of white cells, you cannot have the third room that's there have another white cell. Again, the number indicates how many painted cells there are. Painted cells cannot be connected horizontally or vertically. Okay, so that means the painted cells, the colored cells, cannot be actually horizontal, cannot share an edge with another painted cell. Interesting. White cells must not be separated by painted cells. I'm assuming that basically it's saying, yeah, the white so all the white cells, so this is essentially Nurikabe, I believe, where the white cells have to be all orthogonally connected, which means you can go from any cell in the white region to any other cell in the right region just by going through edges, all while staying within the white region. So basically, for the black cells, they cannot be sharing an edge with another black cell. And the white cells have to share an edge that connects it to all the other white cells on the grid. Interesting. Anyways, so therefore these zeros essentially are basically saying that in those rooms, in those rectangles, in those rooms, there are 0 cells which are shaded in. The dark circles with a number or a question mark inside them. So rectangles have 1 Shikaku clue and up to 1 Heiawake clue. So you can have one this way. And the Heiawake clues are the black digits, and the Shikaku clues are the dark cells, or the dark circles with a white digit inside of them. So remember, every room for Shikaku, every room or rectangle in this grid must have a Shikaku clue. And if the room has essentially a Heiawake clue in them, that's how many shaded cells there are in that rectangle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we have a 5-length Shikaku clue, and it cannot be here. This is a rectangle, remember. So it could be either 5 that way or 5 this way. Well, if it's 5 this way, let's draw borders. So this is definitely a border. This could be 3 that way. We have 2, 4, 2, and 8. We have how many digits? So how many cells do we have? 49. So right now this is accounting for 5. So 8 and 2 is 10. 2, 3, 4, and 5 is 14. So that's 24. So we need to account for another 25 cells. This has 4 cells. Okay, so if it goes 5 this way, that's interesting. How does that work? The 4, so 4 can only be part of, at most, or at least, an 8-cell region. If it's not, the problem is that how do you get 4 dark cells, filled-in cells, into that rectangle? You can't, because then they would be sharing an edge, which is not possible. So you have to have, well, I guess it could be 7. But, yeah, the 7 would have to be a 7 by 1, and it would have to be 7 by 1 that way or that way, which is not possible. So if you had 6 or less, you're guaranteed 2 of those shaded-in cells must share an edge, which is not allowed by Heiawake rule set. So it must be part of 8. So either it's part of this 8, this 8, this 8, or this 8. It cannot be part of 8 going this way. This is 5 here. We've got a random friggin' plane just friggin' doing sonic booms around here. I don't know what's going on. So if it were 8, so say this was 5 going that way. If we had 5 going this way, this would have to be 8 going that way. So then this would be 1, this would be 3. I don't know what this pilot is doing. I don't know why he's sonic booming all around. Oh! Okay, I know what they're doing. Never mind. I do know what they're doing. This is in regards to the Super Bowl, actually. I'm kind of close to where the Super Bowl venue is, and this is probably the, let me take a look. I can't see them. Well, anyways. So, yeah, these are some festivities related to the Super Bowl. So it's probably yeah. Anyways, I gave you a general idea of where I live. Anyways, that's okay. um, yeah, let's continue with this. We have so if there's 3 here, that would mean this has to be, so again, 4 to make that coloring work. This would have to be shaded this way. Oh, this is so let's draw the rectangles then, if that were the case. So we have rectangle here, rectangle here. Shading would have to be these cells for this, and this would have to be shading here to not have any edge. I guess you could have a 9, but the problem is with any 9, you're going to have multiple black circles in them. And that's not allowed. So we can't have 7 doesn't work. We have multiple circles in them. This can't be 7 because it has an 8 in it. And if we tried to have 9, that doesn't work. That doesn't work. There's multiple black numbers, black circles in them, which is we can only have 1. So that's the reason why if this is 5, this has to be 8. The problem is then this white region is not going to be all orthogonally connected, which it has to be for the Shikakawake clues. So that's not going to work. So we know that this rectangle cannot be 5 this way. It has to be 5 that way. So then this is 5 this way. Only one of these cells is colored here. We don't know which. This could be 1, that could be 1. So, okay, what are the possible rectangles this 4 could be part of? Again, it cannot be part of any 9 because that would be now it could actually. It could be no, that would have 2 Shikakawake clues in it, which is not allowed. You could only have 1 Shikakawake clue, up to 1 Shikakawake clue for each rectangle. So if this is 9, that doesn't work. If it's 8, it doesn't work. If this, okay, so this can't be 8 either. So again, you could have 8 here, 8 here. This has to be 8 also. So if we have this not being part of this 8, this has to have an 8 that way. So it could be part of this 8, or it's part of this 8. So these are the same region. This could be 1 and 1. Three has to be, okay, so if This is a region this way. How does the shading work? So it's either this, 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 and this. In which case, this must be shaded here, and this would be orthogonally connected now to the rest of the white cells for now. Or what happens if it's this way? If it's that, 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 and that, this has to exit out, but then that would force this not. Okay, so this cannot, if it's part of this rectangle, the shading has to be like that. Okay. Um, this cannot be, well, it could be 0 and then 0. So again, we can have up to 2 rooms worth of white cells in a row. Okay. This 4 can only be 4, 4, 4, or 4. Um, yeah, I'm used to yin yang. So shit, I was like, wait, what? Can you have 0 there? It's like, oh yeah, you can have 0 for a room's worth. What is this part of as a rectangle? Can't be part of this. That's only 2. It has to be part of either 4 or 3. Interesting. So if that's the case, if this is 3, then this would have to be 0 that way. If it's part of 4, this would have to, it could be part of 3, and then 2. Yeah, I'm not sure how, I've never run into these rule sets before, so I have no clue how to attack what I'm doing right now. 3 has to be part of a 5, a 6, or 5 or above. So it could be part of that. It could be part of this. It could be part of a 3x3. Or part of... Yeah. So this has to go this way. Hmm. So what happens if we do this? Okay. So we know this is a region. That's a region. This then has to form a region this way. And 3 of them are shaded. So it could be 1, 2, 3, or it could be all 6. Ah, then this is problem. Well, yeah, then this cell doesn't have a circle attached, a Shikaku clue attached to it. So that cannot work this way, so it cannot be that one. What happens if we have it this way? So we have it that way, then it's there. This must have 3 shaded region cells. Cannot be 4. It has to be, cannot be 5 going this way. It's just basically 6 then. So this has to be 6 going that way. So this must have some shading that way. This must have some shading this way. So what happens? Okay, so what happens if we have the shading go like that? Then this must be shaded, and that doesn't work. because this cell is not orthogonally connected to the rest of the light cells. And then I think we have something similar this way. So if we have shading here, this must be shaded here because it cannot share an edge with the shading, and then that would necessarily block this cell from being orthogonally connected to the rest of the shaded regions. So we know then this has to be part of this 8 cage because we just tested out both of these and it doesn't work. So then this is part of this 8 cage. It cannot be shading this way because we need one shaded here and then these would not be orthogonally connected. So the shading has to be like this. This must be shaded here to orthogonally connect out. So this is 4. You could have a 9 by 9 here. That is possible. And in fact, it's very likely. Because this can't be part of a region with this. It's either part of a region here or part of a region here. I guess this could be an 8 by 8. This could be 10 by 10. Okay, so this must exit out here. So, okay, these have to be green. This is green, this is green. So these must be green here to be orthogonally connected. Same with this. This can't be blue because it shares an edge with the blue with a blue cell. So this is green. This is green, this is green. Okay. That would be interesting there. This cannot be part of this region. I mean, there's no other cells to be part of. So it has to be part of this region here. It could be a region like that. This cannot be a 8-cell region. It could be a 10-cell region, technically. Or you could have a 9-cell region here, which that has to be part of. So the question is, how does that work? So that could work with 2, 4, and then 3. That works that way. If this is a 10-cell region, rectangle, does that work is the kind of the question, right? You could have 2, 4, 4. You could have 5, 2, 4. Hmm. Okay. Yeah, I have no intuitions about these type of this puzzle here, but hmm. Okay, what happens if this is 9? This would be 2. This would be 4. This would be 3. Ah, because this would have to be definitely be part of uh Shikaku here. So therefore we go there. This would have to be part of Shikaku, so it's part of that. This would also be, this would be 2 that way. This would have to go either this, this, this. So these would have 0 cells, so this must be shaded then. Which means this has to be shaded, shaded, shaded here. But that can't work because this unshaded cell would not be able to orthogonally connect to the rest of the unshaded cells. So it cannot be 9 here, right? Because we need 3 in this region. And this being 0 and this being 0 forces that to be shaded, which means that's unshaded. But to get to that, then that doesn't work because these would both be shaded then because of the 3 shading here. So that cannot be a region. So it can't be 8. It must be 10 then as a region here. This is either part of this or again, so if we had a 5, well, 5 actually might work. So this could be 2, 4, 4, 4, or 2, 4, 4, right? Or 2, 5, and 4. Either way, I don't think you could have a 4 this way, right? If this cell cannot be part of this 4. Because then this is only 2 in length. This is 4. This would be 2. And then this can't be part of a rectangle. So yeah, this always has to be part of this. So we know this is a region. And they're all green. So this must go to, well, it could go to 0 that way. Okay. We know some of these are shaded. So these have to be part of the same region, but it could extend there, it could extend there. We have 3 in these spaces. So if it's 2 and 0 there, that means this is shaded. So that's possible. So we know that's green. Then this must be green. Therefore, this would be a region then. So this would have to be part of that region. So it cannot be the full 4 that way. Yeah, my intuitions here aren't very helpful. Well, I don't even have any Okay, this has to be green. Okay, so this, we know that's there. This has to be green because it's sharing an edge with a blue cell. So this looked like it worked. It had to go there, so this is the full 4 that way. These are all green. These are all green. Oh, that doesn't work because then these would both have to be blue because you can't have more than 2 rooms have consecutive non-shaded cells. And both of these would be blue. So that's not possible. So that means this cannot be 2 going that way. It could be just 2 going that way. Hmm. So then that would be part of this. What happens if we go this way? We know that's shaded. We know, oh, sorry, we know that's green. We know that's green. So again, we cannot be these two because then that would force both of these to be shaded. One of these two is shaded. So say we went this way, okay. Then these would both, okay, so the same problem here. If we tried going here, these would both be green and these would both have to be blue to make sure that you don't have 3 rooms worth of unshaded cells. So this must go this way then. So this has to go this way. We could have shading there or no shading. This is part of 4. This is all unshaded, which means this must be shaded here. This is 2. It must be part of this one. So we have this area here. This is shaded, which means these are unshaded. This must be unshaded to connect for the green cells. We have 3 somewhere here. This part is always going to be shaded. Okay, so this cannot be here, right? This is always part with that, and therefore cannot be a rectangle going that way. So this part is always part of this Shikaku clue. This is always unshaded. So since this is always unshaded, this must be shaded here, because otherwise you'd have 3 rooms that have consecutive white cells. This can't be shaded then because it's sharing an edge with the shared. This is blocked here from being more than 2 rooms. So this could be green-green. No, this cannot be green-green. If this is green-green, that would force blue-blue to be there. This is 2 rooms worth, so this must be blue that way. Which means none of these are shaded. So we have green. This has to have 3 more in this room. So that's blue, green, and blue. Blue forces this not to be blue, so that's green. And this has to be blue because we would have, if this is green, that would be 3 rooms worth of unshaded cells. So this is blue. This is 2 rooms worth, so this cannot be green. It's blue. This is already kind of orthogonally connected. It cannot be the full 4 down here. This is blue, so this must be green here. This is 1, 2. So say this was only 2 in length. I guess that could be blue than green, right? This can't be the full 4 because then you'd have... Actually, it could be the full 4. We have a blue here now, right? So this is orthogonally connected. This is orthogonally connected. So is this. Huh. So we know this is 4. This is 10. We don't know what these numbers are. This is 4. We don't have any. This is done there. Okay. 2 rooms. It's okay. 2 rooms here. 2 rooms here. 1 room here. 2 rooms there. 2 rooms there. 2 rooms there. 1 room there. Okay. This is gonna be, yeah. 2 rooms. 2 rooms. This could be green. That's fine. Can this be blue? Two rooms, 2 rooms. Two rooms, 2 rooms here. 2 rooms, 2 rooms, 2 rooms there. If this is part of there, then this would have to be blue. That would be green, blue, green. I mean, that seems fine. If it's 4 here, okay, can this ever be part of this? So this would have to be blue here. Green going this way. So it'd be 3 that way. And then these would be 3 rooms with green, which is not allowed. So this cannot be part of this. So this is done here. So this is 1 room. Obviously can't be the full 4 that way. This is now part of this region here. So this is 2, this is how does the shading here work? So this is 2, this is 1, and obviously this is 4. Obviously one of these two needs to be shaded. If this is shaded, if this is shaded, if this is shaded, this is green, but then you'd have 3 rooms worth of green because you can't have this be shaded. That would block this off. So this cannot be shaded. This is green. Therefore, we have 2 rooms worth here. This cannot be another green because that would be 3 rooms worth. So this is blue, which forces both of these to be green. So this is the shading here. 2 rooms worth going that way. 1 room. Let's okay, 2 rooms, 1 room going this way. 1 room. 2 1 2 rooms. 2 1 1 2 1 2 1 going that way. This is 1 room, 1 room, 1 room, 2 rooms, 1 room. 2 2 2 1 1 2 2 1 2 2 0 2 2 2 1 in those rooms. And so that's the shading. No 2 rooms have unshaded in a no 3 rooms have unshaded cells. Size 2, size 4, size 2, size 4, size 3, size 2, size 10, size 4, size 8, size 5, size 1, size 4. And this has 0 shaded cells, 0 shaded cells, 0 shaded cells, 4 shaded cells, 1 shaded cell, and 3 shaded cells here. So that's the solution. I don't know if I would consider this easy. Maybe it's just because I have no intuitions about these types of puzzles, but it didn't seem easy to me. I felt more challenging level, but maybe that's just me. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.